Okay, so today we're going to move on to multiplying two binomials, which actually, to be honest, sometimes I think I should teach this first because it's actually, I think, a little bit easier than what we did yesterday. So basically, it's an extension of the distributive property, which you guys would have done in grade 9. Okay, so we reviewed this in 5.1, but let's do it again. So when you have a number out front, you multiply by both numbers inside the brackets. So 4x plus 12, 4 times 3, and then you can do variables, which are letters as well, so you get 5x squared minus 7x, or you can do numbers, and variables. So 5x times 3x is 15x squared. 5x times 5 is 25x. So now, yesterday, what you would have, or the last lesson, what you would have done is taken, say, this term and gone the other way, okay? But today we're going to focus on expanding, except we're going to do two. We're going to do double, which is often called FOIL. And FOIL stands for first, outer or outside, inner, inside, and last. So it's just a way to make sure that you're multiplying everything from one bracket with the other bracket. So we're multiplying binomials, which means they have two terms. Okay, so here we have, this is the general form. So if you have A plus B times C plus D, then it's A has to be multiplied by everything in this bracket as well. So does B. So the way that we can deal with that is to do FOIL. So first, so A times C, and then outer, A times D, inner or inside, B and C, B times C, and then last, B times D. And it really doesn't matter when you're multiplying, right, which one you technically do first. It's more about making sure that you're multiplying every term in the first bracket by this term in the second bracket. And then you're going to see that this also involves collecting like terms, which is also a skill from grade 9. Okay? All right. So we're going to expand, and it's going to say expand, which is the FOIL part, and simplify, which means there's always going to be two terms in the middle that we have to collect. So there's always going to be two, usually we use x, but doesn't always. So I don't want to say two x terms, but in all our examples, there's going to be two x terms. So you can see here, we did x times x and got x squared. Then x times 5, so outside 5x, and then inside 2 times x, and then last 5 times 2, which is 10. So now we've got these two terms here in the middle, which have to be collected. So there's only one x squared term, but then there's 5x and 2x, which means 7x when you add them together. And then the 10, there is no other number as well. So there can be, in the next example, it's got a number out front. That's fine too. You do the same thing. So first, 2x times x is 2x squared. Outside, 2x times 4 is 8x. Inside, now that's a -1. So that's -1 times x. So I'm going to actually even write the -1 to emphasize that because it makes a difference. And then -1 times 4, which becomes -4. So then again, always in the middle two terms are there, you're going to have to collect. So now we're doing +8 plus +8x minus 1x, which is +7x. Okay, so the first terms are the ones with the x's, so you're going to get x squared because when you multiply the same base, you add the exponents like we did in the first example, first lesson. Okay, and then we had to collect like terms today. So the questions are going to say expand and simplify. So again, expanding is FOIL and then making sure you collect like terms. Okay, so first, x squared outside, 7x inside, 3x, 3 times 1 is 21. And then 7x plus 3x is 10x plus 21. Here, x squared outside. Now, again, there's that negative 5. Inside is positive 5. And last is negative 25. So we get x squared. Negative 5x plus 5x is going to be 0x. So this is actually a special case we're going to deal with later on as well, called a difference of squares. So both the x squared is a square and 25 is 5 squared, right? So that's a special case. You want to make a little note of that. Why not? And it's called the difference of squares. And the reason it's called difference is because it's subtracting the two terms in the middle there. And it always will be. Okay, so that's a special case. That's 5.5 when we get there. Okay, not so bad. Let's do some more examples. I don't know what's going on here. All done there, right? Okay, so now we have some more. First, x squared, outside, negative 4x, inside, negative 3x, and last. So now we've got negative 3 times negative 4, which is going to give us a positive 12. And collect the like terms in the middle, 7x, negative 7x, plus 12. And again, if you don't know how, if you can't do negative 4 minus 3 in your head, just put it in your calculator. Okay, you can't put the x's in. You just have to make sure you include those when you do that math. Okay, so then we're going to do, again, one with a number out front, no big deal. 2x squared outside. Now we've got negative 14x. Inside, negative 3x. And then last, negative 3 times negative 7 is positive 21. So negative 14 minus 3 is negative 17. Again, if you can't do that in your head, there is no problem. And again, you just like the first lesson, you don't need a really super complicated calculator. You can just use a normal phone or whatever, okay? Okay, so now both of our first terms have numbers, which is fine. You just multiply. 2 times 3 is 6. X times x is x squared. And then when you do the outside ones, you're going to do 2x times 2, which is positive 4x. The inside 1 times 3x is 3x. And then last is 2 times 1, which is 2. And then collect like terms. Okay. F looks a little bit weird. Really what you should do is rewrite this. When it's squared, then that means you're multiplying by itself. So it's really 2 brackets of the same thing. So I would just rewrite it and do the same thing. First, outside, inside, and last. Again, if you don't know what negative 14 minus 14 is, just do it in your calculator, okay? No harm, no foul. Okay, so the last two examples have more than one step, but that's not a big deal. There's a number out front. So what I would do is I would wait till the end to take care of that. Okay, so I would FOIL first. Sort of like BEDMAS, right? Take care of the brackets first and then multiply by 3. Okay, so I'm just going to keep the 3 there. Because we have to multiply by 3 eventually, the new expression we're going to make should still stay in brackets, but only one set. So x times x is x squared first. X times 6 is 6x. 5 times x inside is 5x. And then 5 times 6 is 30. Okay, so now you can choose to multiply the 3, or you can simplify first. If you simplify first, then there is less multiplying, but it really doesn't matter. Okay, so now we're going to do the 3 by everything. Now this is just like regular grade 9 distribution. Okay, so now we're going to do 3 times x squared is 3x squared. 3 times 11x is 33x. And 3 times 30 is 90. So now this looks more like a situation where you would have to say to yourself, if you were going to factor this, which is to go the other way, you would be like, oh, there's a greater common factor here of 3. I have to get rid of that first. Okay, so you can that's eventually what we're going to do. And this one, you just have to be careful. It's the same thing, FOIL first, but then when you multiply, the 2 is negative, okay? So negatives always change the signs and mess things up. So x times x is x squared. X times negative 9 is negative 9x. 1 times x, again, I'm going to write the 1 in there just to emphasize, and then 1 times 9 is negative 9. So then negative 2, you need to multiply by, I just did it a different way. So I will simplify first. Let's do that. Negative 9x plus 1 is negative 8x. I could have done it the other way, but this is less. Seems like less work or something. Okay, so negative 2x squared plus 10x plus 16x plus 18. Okay, so yes, there are a lot of questions here for homework, but it's one of those things where I tried to even cut it down, but if there are if you do a bunch and you're like, okay, I get how to do this, please don't feel like you need to do every single one of these questions. But make sure you do try some of the ones that are a little bit weird and a little bit tricky. Okay? And one of the reasons that FOIL is going to be so useful, because eventually we're going to call this standard form. So when you multiply, it actually doesn't matter really what order you do it in, but standard form, we want the x squared term first, and then the x term second, and then number third. That is going to be very important as we move forward. So doing FOIL and making sure you have the x squared term first, you collect the like terms in the middle for the x term, and then the number goes last, will become imperative. So you might as well get used to it now and just do this format. Okay, thank you. If any questions, please email.